Hi, I'm Jose Abel, civil engineer. This is somewhat of an improvised video. So I was teaching finite elements yesterday in my class, and we were trying to, we're starting the class, so we're trying to generate a little truss analysis model and set it up in Python, and to talk about the direct stiffness method and elements, and give a general framework of what a finite element program looks like and the different parts. So at one point I decided to ask ChatGPT to generate a truss, a function that would generate the stiffness matrix for a truss in 2D. And it went ahead and it did it for me. I was very impressed with what it could do. So then I was asking some other things to ChatGPT to generate for us. If you don't know what ChatGPT is, so ChatGPT is a language model, which is a general language model that is an artificial intelligence that is for language processing. So you can ask him random things and it'll give you an answer based on what it's been trained to do. And it can write code for you. So let's do just that. Let's ask ChatGPT to generate a finite element function in Python for us. So the prompt I have ready over here is, please generate a Python function for a CST, constant strain triangle finite element for elasticity. Let's say for plane stress elasticity, and see where this takes us. So ChatGPT is thinking, and it should give us an answer to our problem. Sure, here's an example Python function for a CST, and it knows that it's a linear triangular element. So it starts importing NumPy. This is awesome. It gives you, okay, so as input we're getting E, that is the Young's modulus, and it's writing documentation for us. This is pretty amazing. So E, the Young's modulus, nu is the Poisson's ratio, the thickness of the element, and then we have lists for the coordinates of the elements. These should have length 3, and then it returns, look at that. It's even going to give us the element nodal force vector. So it should return these two things, and it's writing code. It's writing code for us, a finite element that we can then use for something. So what I want to do today is to try it out and see what's going on here. Okay, so it's compute the element constants. I don't know what it means by element constants. This is different to the code that it generated yesterday for me, but here it's writing the mapping. So this A matrix is the mapping from triangular coordinates into XY domain. So when you can get the area of the element by taking the determinant of this matrix and multiplying that by 1/2. And then it's getting the strain displacement matrix. This BE is the strain displacement matrix. The material matrix, this is a plane stress constitutive matrix. And then what is it doing? It's transposing it, and then it's computing the stiffness as B transpose times D times BE. And then it's computing a 0 force vector. So this force vector is not going to change. So let's grab this code and try it out. But let's try it out. Okay, let's go here, and we're going to call this truss.py. Okay, so this should be valid Python code. Okay, so it runs. So that means there's no syntax error. So let's ask ChatGPT. What else is it saying here? This function takes the Young's modulus, Poisson's ratio, thickness, and the XY coordinates of the element nodes, and returns a 6x6 element strict to this matrix, 6x1 element nodal force vector. Note that this function assumes that the input coordinates are in a counterclockwise order, of course, because otherwise you get a negative area. In this context, the area is a signed value. Okay, so can you use this function to solve a simple problem where you have a rectangular domain which is fixed on two sides? I'm not going to specify which two sides. A rectangular, let's say 2 by 3 meters domain, which is fixed on two sides and subjected to a point load in the middle of its top side. Let's see if it can do this. Send. I'm pretty impressed. Like, I need to take into account the fact that now my students have access to this technology, and that probably means that we can get more done. Okay, sure, here's an example Python script that uses this. Okay, define material properties, define the domain. I didn't specify the thickness, so it assumed a 1 centimeter thickness. This is awesome. Number of elements in each, okay, so it's assuming 2 elements in the x direction, 3 in the y direction for some reason. What is L and what is the x direction for this thing? So the x direction, it's going to have 2 elements in the x direction, 3 in the y. We found the boundary conditions. So we're going to try out this code, see if it does anything for us. Assemble global stiffness matrix. So you're getting, okay, so it created a grid for us. And it's a regular grid, of course, that's what you would do. And then for each of these, you need to, what's going on here? This is interesting to watch, this is so interesting. So it knows, oh, look at this. It's using a little matrix, so it's gonna use sparse allocation for the K. That is awesome. Look at this, so it's getting a sparse matrix for its a matrix representation. It knows that it doesn't want to store the zeros as part of the stiffness matrix, so it's going for an LIL matrix. Let's see what it applies boundary conditions. And is that as far as it got? I think that's as far as it got. So let's copy this piece of code and see what happens. So I'm just going to create here, let's call this, no, new file. Where did I save this, by the way? So blind folder. Where am I saving that? No, it should be projects, FemGPT. This one, save. And then in this same folder, sorry, rename this file. I messed it up. Truss.py, and then a new file that I'm gonna call no, it shouldn't be called truss. It should be called something else. CST. So CST analysis.py. I'm gonna paste this, keep it there for a while. But then, so where am I using this? So I should have the function CST plane stress element imported. So I'm going to rename this this file. Rename. Please rename. Let's call it CST plane stress element.py. Okay, there we go. And then CST analysis, and then I'm going to add here because it's not adding. Import CST, no, from, we're going to import CST plane stress element and try to run this. Let's see what happens. Shapes are not aligned. So let's think about this a little bit. Let's see if we can get it to do something. You're not done. So I think it ran into that 1,000 character limit. So I should be able to get it to continue if I just tell him he's not done. But then it doesn't provide a, I mean, it'll take into account, there you go. Oops, sorry about that. Here's the rest of the script. Apply the point loads. So it knows where to apply the point load, apparently. I don't know if this is right. But we already know that this code is not running. So let's take a look. I'm so impressed that it's using a sparse solver. Okay, so the error I got is in line 46. In line 46, over here, oh, inside the CST element, so line 39 of the CST element. Line 39. These matrices are apparently not aligned. So this B, yeah, this B matrix doesn't look right, because this B matrix should be, yeah, it's missing a whole row. this B matrix should be, so it's a strain displacement matrix, so you get the epsilon from BE times U. U in this case has a size of 6 by 1, so it's 6 degrees of freedom for this element, and epsilon should be the strain, and that should be 3 by 1. That means BE should be actually 3 times 6. So I'm seeing here that I think that dimension is fine, but we're missing a row. So and I'm not even paying attention to what's going on. So apply point load, and then solve for displacements, and then it's plotting for me. So the script uses this to assemble those. You can modify material properties, problem geometry. That is fun stuff. So let's add the rest of it in here, and I'm actually going to tell it, give it the error. So here, thanks. When you run this, I get the error. Let's see what it does with this, because it should be able to interpret this. Oh, it looks like the error is being caused by the shape of the BE and DE matrices not lining up. Wow, it knows about its own stuff. This is awesome, actually. This is so cool. So let's see. To fix the error, you can check the shape of the matrices and make sure that they're the correct size before computing the dot product. Okay. So it didn't give me the fix. It didn't give me the fix. And it's definitely that B. Okay, let's go here, and DE. DE is fine. DE looks like it has a size, so it's a 3 by 3 matrix. It should be what we have. So this is almost right, except I'm going to erase this comment, and I'm going to tell ChatGPT, you gave me this expression for the strain displacement matrix, which is wrong. It's not of the correct dimensions. Can you fix it? I know what the fix is. I want ChatGPT to give us our stuff. Let's see what happened. Ooh. I apologize for the mistake in my previous response. Here we go. The BE matrix should have a shape of 3 times. No. Well, by 2 by 3. No. This is not right either. Nope. The BE matrix, let's use the same language he's using. That is the BE matrix should be 3 by 6, so that the B transpose D B product works. I apologize for the confusion. You're correct. Of course I am. I teach this stuff for a living. Zero to 2. Does this even make sense? I think this is getting it right. So 0 and 1. No, this is all wrong. Okay. No, because, okay, no, the 0, the first 2 columns. Huh. No, this is not going to work. I'm pretty sure it's not going to work. So let's just copy paste it into the code. But the size is right, I think, this time, but not the not what's going in there. So let's go back to CST analysis. And yeah, local bar B, reference before assignment. This one. So let's actually, we are going to need this. And matrix exactly singular. Yeah, no, I don't know what that is. Okay, so we're 15 minutes into the video. I think this is good news in a sense, because it can help you out. Like, this is a lot of work. Like, this is the structure that a function for a stiffness matrix of a CST element should have. So you should have this, but we know here that the BE is wrong. The DE looks about right, and this is the express. So as a user, as a developer, if I want to do this, if I want to work on finite elements and I want a little CST plane stress element function, I tell ChatGPT to create an initial implementation, and then I fix what's wrong. This looks right, except for the BE. This does not look right. Yeah, so this is exactly wrong. This is not the structure that this B matrix should have. But then let's take a look at the analysis. So the analysis part is generating a mesh, and you could actually change here the number of elements that you want in each direction. So it's flexibility. So this is a very good template for you to start working on something, and then just focus on fixing the problems. And you can actually use ChatGPT to interpret the errors that you get. For example, let's see what happens here. It's not going to know what to do with this, definitely, because but let's see what happens. I'm getting the error. So the B is wrong. That means that probably the global stiffness is all corrupted, and it's not right, so it's singular. Yeah, it suggests that the matrix being used is not invertible, which can occur if the matrix is linearly dependent. Okay, so it's going into explaining what the problem is. One possible reason for the singularity is that the element nodes are not arranged in a counterclockwise order. This can cause the Jacobian determinant. Is that the case? So if the elements are not in the correct order, then I should get an AE, which is negative. So let's actually print the value of AE like this. If I'm getting a negative or incorrectly ordered, yeah, so there's a bunch of elements that are incorrectly ordered. Okay, so that might be part of the problem, but I know that for sure the BE matrix is not right. Okay, so my main point is ChatGPT is an awesome tool, but you need to use it with care. Like, it's going to generate stuff for you, it's going to save you time, but it's not going to be right. And if it generates code that gives you stuff, you still need to check to see if the results that you're getting are correct. And if not, you're in a heap of trouble, because it's code that you haven't written yourself, and it's going to end up being possibly harder to debug if you don't understand exactly what's going on. So I see myself using ChatGPT to generate fast code for me, but then going in and messing with the parts, or filling in the blanks, or fixing the stuff that it gets wrong. But in order to be able to do that, you have to have a strong theoretical grasp. I need to be able to read this code and understand exactly what ChatGPT is doing it and why, which I can do. It makes sense. It's a code that makes sense, and I can identify that there's an error here, exactly in the strain displacement matrix. And on the other hand, over here, so when I interpreted the error given by the solver, that the matrix is singular, I initially thought that the whole deal might have been only the BE matrix, but ChatGPT is right in this case, because there are some nodes here that are giving me a negative Jacobian. I printed out the value of the area, and I'm getting some negative areas. So that means there's also a problem here in the way ChatGPT is numbering these nodes. These nodes, and I don't know why are we getting 4 nodes? Yeah, this is something else. Anyway, that's gonna be for this video. I hope this helps you a little bit, guides you on how to use ChatGPT for your stuff. I'll be for sure coming up with more videos on how to use ChatGPT efficiently for finite element programming as I start using it myself. So cheers.